But I think what we could hear from Eike's presentation is that when you change from fluoride-free from PFAS foams to fluoride-free foams, you will likely have to replace some parts in the system, those parts that you cannot clean. So you will have different kinds of waste streams coming from this process when you go into fluoride-free. You have the foam concentrate waste, like the foam that you have not used yet, which is perhaps in the containers. Or then you might, if you have a premix system, then you might have the foam concentrate in water, when it would be less concentrated, but there could be large amounts. And this, in some cases, you would have this also with portable fire extinguishers. And of course, in case of a fire, you would have fire waters that would contain the firefighting foam. Then you would have firefighting equipment that has been in contact with the foams, like we saw the mixers and pumps and tubes and pipes and nozzles that could be contaminated with the PFAS to the extent that they would have to be managed as PFAS foam. And then you have the cleaning waste, which basically means the water or any other solvent that you use to clean up the systems. Another way of looking at it, you would have both liquid and solid waste. That could be hazardous waste. It could be PFOS waste. Or then it could be non-hazardous waste. So different regimes would come into play here. One of the things that I have found surprising is that the waste legislation in the EU is much less harmonized than the chemicals legislation. So what this means is that the waste, for example, firefighting foam waste, could be classified differently in different countries in the EU. So mainly this would be the waste codes that are assigned to this. It could be different authorities in different countries could be different waste codes for the firefighting foam waste, for example. And in many cases, this is because the waste management powers in some cases are with the municipal authorities, or they could be in the regional authorities, or with the state authorities, but there is a variation in this. And that's why even within the EU, the basic waste legislation and the authorities may vary a lot more than in the chemical side. So the local regulations always need to be observed. In the EU, we have the EU Waste Directive, and it's a directive, which means that you have to harmonize your national legislation, which does set the basic concepts and definitions that are related to waste management, and also related to recycling and recovery of waste. There are requirements that you have to implement for labeling, record keeping, monitoring, and these are really general, these are related to all waste. It also bans mixing of hazardous waste with other categories of hazardous waste and with non-hazardous waste, and the idea is that you wouldn't get rid of your hazardous waste by diluting it with non-hazardous waste. And there is a system for classification, which is in this directive, for how to classify hazardous and non-hazardous waste, and also the labeling. So there is harmonization, but it's not as complete as in the cases where you have chemicals regulations, which are the same for every country. So I'm just as an example giving examples of Finnish waste legislation, which is based on the EU directive. So what we have elements that are relevant in our basic waste legislation for these is that discarding and uncontrolled management of waste is prohibited, so you have to deal with the waste intentionally. And you also have to take into account that waste or waste management is not allowed to cause harm into the environment or human health or general safety. The reason why this is important as a general rule is because when you have waste that is difficult to classify as hazardous waste, or it could be non-hazardous waste, but it still might contain PFAS, for example. You would still have to adhere to this thing. You might still have to treat it as, for example, hazardous waste, even though it's not technically hazardous waste, because that's the only way to make sure that you do not cause harm to the environment or human health. And there is a need, a third element, which is relevant for such waste that is not hazardous waste or POPs waste, that you need to use best available technology and best environmental practices for managing that waste. There are sub-legislation and acts that give much more detailed provisions for the general waste management, like for example what we have for e-waste or other. So basically when we think about the foam waste, and I have to say that I haven't coordinated this with ICE, so if you have any corrections that you disagree with how it is in Germany, please go ahead. So the regulations should be clear if the waste, the foam waste, is hazardous, or if it's POPs waste. In the POPs regulation, there is a requirement in Article 7, and I will mention that later on, that waste containing POPs has to be managed in a way where the POP content is destroyed. So that is pretty clear. But for hazardous waste, it's an independent classification from POPs waste. So hazardous waste in this legislation is that if they contain hazardous substances above the levels that are specified in the Waste Directive Annex 3, it should be treated as hazardous waste. With firefighting foam concentrates, the PFOS content is just a few %. So, but there's a lot more solvents. There'll be glycol or whatnot. These are commercial secrets to a large extent. But there could be other things than just PFAS that actually cause these to become hazardous waste. So that is like one thing. And then we have the POPs waste. And this is only relevant, of course, for those POPs chemicals which are listed in the POPs regulation. POPs waste is technically everything that exceeds the limit that we consider unintentional trace contamination. But there are several separate limit values in POPs regulation Annex 4, which set when you have to treat the waste as POPs waste, which means practically that you don't have any other choice but to destroy it in one way or another. And if we look at these differences, you have like the 25 ppbs for PFOA is the limit here, the unintentional trace contamination. But for Annex 4, when it becomes POPs waste, it's much higher, it's 40 milligrams per kilogram. So, in case it doesn't classify as hazardous waste or it doesn't classify as POPs waste, you will still have to apply with those general principles that I showed in the previous slide, which come from general legislation. I'm just going to show this, that this is from the POPs waste limit values. So here basically we like arrows apparently in this discussion. Here we have the unintentional trace contamination value. So below that, it's considered that POP does not exist, so it's not restricted if it's below the 25 ppb in the case of PFOA. And then we have in the Annex 4, we have the lower POPs waste limit value, and in Annex 5 we have the upper concentration limit. And this is something that is not in Stockholm Convention at all, but this is in the EU legislation, that between the lower POP limit and the higher POP limit, there are cases where it's possible to treat the waste in other ways but destruction. For example, by placing it on hazardous waste landfill. But only in case this is environmentally better than destruction. We have cases, as an example, this is not related to foams. I think in foams, you would always have to consider that environmentally sound destruction is the only way to go. But for example, if you have contaminated soil that is contaminated with dioxins and furans, normally you could take that to incineration to destroy the dioxins and furans. But if it's also contaminated with mercury, then you wouldn't take it to incineration because the mercury would be released into the atmosphere, and that's why you might be able to justify that the environmentally better way is to stabilize it and place it on a hazardous waste landfill. So, how do you destroy these waste? And this is also a little complicated. Those PFOSs that are listed in the POPs regulation, PFOS, PFOA and PFHXS and their related substances, the Article 7 of the POPs regulation provides that the waste must be destroyed so that it does not exhibit POPs properties after that, which basically means that the POP molecule is destroyed one way or another. Basel Convention, the International Convention on Waste, has developed technical guidelines that provide some additional information, and what it says, and this is regarding to PFAS containing POPs waste or POP PFAS waste, that you basically have a possibility of incineration, which is in high temperature, or then in cement kilns, which is also high temperature, or then you could have these physical chemical treatments like gas-phase chemical reduction or supercritical water oxidation processes. These are very minor compared to the scale of high temperature incineration of cement kiln capacity. In some cases, you could have recycling or reclamation of metals and metal compounds as applicable, and I will come to this later. So, if it is considered hazardous waste, you basically have high temperature incineration or cement kiln. And now we also come back to this National Waste Incineration Act. We have a limit of 1% for organ allergens, which is fluoride would be one of those, that any hazardous waste that contains more than 1% of fluoride must be destroyed in high temperature incineration. So this is pretty clear. And then the same waste incineration also requires that because you have to use best available technology or best environmental practices, practically what we consider follows from that even non-classified AFFF or other foams containing PFAS must be destroyed in high temperature incineration or cement. The beauty with non-fluorinated foams would be that you might also be able to destroy those in a regular waste incineration facility, which has a lower temperature of 850 degrees, provided that the environmental permit allows it. And this is in case they are not considered hazardous waste. Okay, that's with the foams. Now, a lot of wastewater comes out of this process of cleaning, and the concentration of that water varies. It depends on what you do and in which stage of the process you are at. Towards the end of the process, when the system becomes more clean, the concentrations are lower. Different countries have different limits for what can be released into the environment or wastewater treatment. This might depend on the environmental permits. You might have a different, your facility might have an agreement with the wastewater treatment facility that sets limit for the PFAS that you can let into the sewer. And in the case of Helsinki wastewater treatment, we have a limit of 5 nanograms per liter for PFOS and PFOA in incoming wastewater. And in Daniel's presentation, we remember that the drinking water directive limit value for PFAS was it 500 nanograms per liter?
Yes, for the sum of all PFAS.
Yeah, for the sum of all PFAS. Our wastewater treatment facility has limits only for PFOS and PFOA, but this is really low. I have no idea how they enforce it, but this is in the contract between the industrial source of wastewater and the wastewater treatment facility, they have said that this is what we can accept, and if you exceed it, then you're violating. In New Zealand and Australia are really like, they have been doing this transition a lot longer than we have been doing in Europe. They have set guidance values for the water that is coming out of the cleaning process, like here. So this would be 100 nanograms per liter for PFOS and PFOA, and 1000 nanograms per liter for total PFOS, which is a little higher than what we would accept in our drinking water, but shows that we are talking about really low concentrations on what is accepted. And here you can see the picture of Australian firefighting truck cleanup process, and I think they mentioned that you get 6,000 to 8,000 liters of wastewater from cleaning one truck, so significant amount of waste. And then you have these solids, and this really beats me how to implement POPs regulation with the solids. Let's say that you have you could have solid waste coming from parts that are not compatible with the new foam and will need to be disposed of. I get in the previous presentation mentioned that you have to use a lot more foam, which might mean that you would have to change some physical parts in the system. So what do you do with the old parts that are not compatible with the new foam? They would have to be considered waste. So there might be mixers and nozzles and pipes and whatnot. And if it's a metal object like a nozzle, what we would have to consider is that what is the PFAS concentration in, or a pipe? Let's think about a pipe. What is the PFAS concentration in a metal object? There is PFAS layer inside, but does that exceed the limit value for POPs waste or hazardous waste, or probably not, because the metal is a lot heavier than the PFAS layer inside. So we might be talking about, if we look at this in the sort of traditional sense, as we would be considering like whether the plastic in the television is considered POPs waste. It's a lot easier because it's very homogeneous. But it's clear that the internal layer in this pipe would be hazardous waste, but because it's part, it's like one thing, and even after cleaning, so you would be able to classify it differently. So we're kind of in a difficult territory here. Like, what should you do with these pipes? And we have considered that it would be okay to recycle these, because the PFAS would be destroyed in the process where you melt the metal. So metal recycling would be an option for example, firefighting portable extinguishers that have a metal container, and you empty and clean and recycle the metal. But then we have this issue of very porous objects, which are like hoses and rubber objects, so old firefighting foam containers that may be porous inside, and they would have to be disposed of. And in this case, our solution would be that the only option is to put them for disposal in high temperature incineration. But most important thing here is, of course, that you shouldn't reuse any of these. You shouldn't use the containers, and you shouldn't reuse the tubes in any other purpose, no matter how well they have been cleaned, because you cannot get to zero anyway. So I think this is my last slide on this, and this is where I'm telling what I think about this. That recommendation is that with the foam waste, it should always be treated as hazardous waste and destroyed in high temperature incineration or cement kiln. And this would include foam concentrates, it would include porous materials that have been in contact with the foams, hoses, containers that are difficult or impossible to clean and continue using them, plastics that are not suitable for use with the new foam that you put in, and also cleaning waters with high concentrations of PFAS, which is like the first cleaning waters that you would have. With these, of course, there is an option that you would have a cleaning process to remove the PFOS from the cleaning waters before you would release it into the sewer. And we have some experience on this, which is really related to fire waters that have been collected from a fire incident, which contain the firefighting foam, but also everything else that comes in that fire, which is typically like lots of problems with that water. But it still seems like it's the costs of purifying that water would be like 1/3 of what it costs to put them in high temperature incineration. So it might be an option. What I can also say about is that, for example, what they do in New Zealand is that when they do this cleaning and they have the first highly contaminated waters, the cleaning waters, those would be sent to high temperature incineration, which they don't have in New Zealand, so they send them to France. And then the lower contaminated waters could be purified with absorbents like here. Most importantly, you have to treat this according to the national and local requirements, which means that there is very difficult to put any clear-cut restrictions from the EU, except of course what we have in the POPs regulation when it comes to POPs waste. And this would be like where you have to consider what to do with the waters with low PFAS foam concentrations, but mainly this is going to be a lot cheaper than high temperature incineration, which would be like more than 1,000 euros per ton. And then considering this secondary metal production, which is recycling them as metals, like metal objects that are difficult to clean or are not useful in the new firefighting foam system, you might be able to recycle those as metals. Concentration in a metal object. There is PFAS layer inside, but does that exceed the limit value for PFOS waste or hazardous waste? Or probably not, because the metal is a lot heavier than the PFAS layer inside. So we might be talking about, if we look at this in the sort of traditional sense, we would be considering like whether the plastic in the television is considered PFOS waste. It's a lot easier because it's very homogeneous. But it's clear that the internal layer in this pipe would be hazardous waste, but because it's part, it's like one thing, and even after cleaning, so you would be able to classify it differently. So we're kind of in a difficult territory here. Like, what should you do with these pipes? And we have considered that it would be okay to recycle these, because the PFAS would be destroyed in the process where you melt the metal. So metal recycling would be an option for example, firefighting portable extinguishers that have a metal container, and you empty and clean and recycle the metal. But then we have this issue of very porous objects, which are like hoses and rubber objects, or old firefighting foam containers that may be porous inside, and they would have to be disposed of. And in this case, our solution would be that the only option is to put them for disposal in high temperature incineration. But most important thing here is, of course, that you shouldn't reuse any of these. You shouldn't use the containers, and you shouldn't reuse the tubes in any other purpose, no matter how well they have been cleaned, because you cannot get to zero anyway. So I think this is my last slide on this, and this is where I'm telling what I think about this. That the recommendation is that with the foam waste, it should always be treated as hazardous waste and destroyed in high temperature incineration or cement kiln. And this would include foam concentrates, it would include porous materials that have been put in contact with the foams, hoses, containers that are difficult or impossible to clean and continue using them, plastics that are not suitable for use with the new foam that you put in, and also cleaning waters with high concentrations of PFOS, which is like the first cleaning waters that you've done. With these, of course, there is the option that you would have a cleaning process to remove the PFOS from the cleaning waters before you would release it into the sewer. And we have some experience on this, which is really related to fire waters that have been collected from a fire incident, which contain the firefighting foam, but also everything else that comes in that fire, which is typically like lots of problems with that water. But it still seems like it's the costs of purifying that water would be like 1/3 of what it costs to put them in high temperature incineration. So it might be an option. What I can also say about is that, for example, what they do in New Zealand is that when they do this cleaning and they have the first highly contaminated waters, the cleaning waters, those would be sent to high temperature incineration, which they don't have in New Zealand, so they send them to France. And then the lower contaminated waters could be purified with absorbents like here. These have PFAS releases is another thing. There is a very recent study from Sweden where they estimated PFAS emissions from a municipal solid waste incineration facility. And I think it was like 45 grams a year that was coming in either in the wastewaters that come with the washing of the exhaust gases, or then in the different slags that come out of the process. The problem with these estimates is that nobody knows how much is going in, so we don't really know what is the conversion rate, because PFAS are coming to the incineration facilities from households and from industries, and you don't really have a good mass balance of this. But the Americans have been very, very concerned about whether destruction is sufficient to destroy the PFAS. But on the other hand, the Americans have also been using lower temperature than what we are using in the EU for high temperature incineration. But on the other hand, we know that all the time PFAS waste is going to regular municipal solid waste incinerators, which only operate in about 850 degrees. And foams should not be taken there, that's for sure, but all foams are not automatically considered hazardous waste, so we can't really rule that out either. Some are putting foams directly into the sewer.